Hey folks, Ms. Gosling here to discuss the motion of projectiles in the x direction. To do this, I'm going to look at the following problem. A cannonball is launched with an initial velocity of 20 meters per second at a 45-degree angle. How far will the cannonball travel? Now, this problem is actually the same as the problem we solved in the previous video. However, we are now looking at the x direction instead of the y direction. And what I'm going to do is I'm going to go ahead and just pull up the information from the previous video for you guys. So in part A of the previous video, we figured out the maximum height. In part B, we figured out the time that it took for the projectile to reach that maximum height. And we also figured out how long the projectile would be in the air. And it is this last part, the air time, that is really important to our problem. I'm going to go ahead and shrink this for now, but we'll get into why that is in a moment. So to figure out this problem, I'm going to start by just highlighting the question. How far? When we see how far, what you should immediately think about is the displacement in the x direction. So that is going to be the range of the projectile. Now I have what I need to write out my givens and my unknowns and continue solving this problem. So my givens here are that the initial velocity of the cannonball is 20 meters per second, and it's at a 45-degree angle. So let's go ahead and draw that in. We have a 20 meters per second, 45 degrees, and I can go ahead and solve for my initial velocity in the x direction because I know that ux is going to equal 20 times the cosine of 45. And again, if you are struggling with your trigonometry, please go back and try looking through the first two videos to help clarify things. However, if you are comfortable with trig, let's go ahead and continue. Plugging that into the calculator, we find that the initial velocity in the x direction is approximately 14 meters per second. If you did not get this number, double check and make sure that your calculator is in degree mode instead of radian mode. Now, there is one other thing that I know, and that I only know because I solved for it already. Typically, you will not know this, and you'll have to solve for this, but because I've already solved for T air, I'm going to go ahead and write that out as a given. Again, normally you will have to solve for T air the way that we did in the previous video, but in an effort to keep this a little bit shorter, I'm going to not do that again. So here, our initial velocity is 14 meters per second, and our air time is 2.8 seconds. Now, let's go ahead and do my unknown. And again, I know from the question that my unknown is the displacement in the x direction. Now I'm ready to go ahead, pick an equation out, and solve. So let's go ahead, go to our equation, and you can go ahead and do your Suvat table. However, because we are in the x direction, I have one more given, and that is that my acceleration is 0 meters per second squared. Because there are no forces acting on our projectile in the x direction, and so it will not experience any acceleration at all in that direction. And what that means is I can use the definition of velocity to figure out my displacement. So the equation I am going to use is v equals displacement over time. And I'm going to go ahead and say velocity in the x direction is equal to displacement in the x direction divided by time spent in the air. And let's go ahead, substitute in numbers, and solve. So sub and solve. The initial velocity in the x direction, which is my velocity, again, the entire journey in my x direction, is going to be 14 meters per second. And that is going to equal my displacement, which is my unknown, divided by my air time, which is 2.8 seconds. And what I will find is that the displacement in the x direction, my range, how far the cannonball will travel, is about 40 meters. And there you have it, folks. Now you know how to solve for your displacement in the x direction.